Question number 8. The number of nearest neighbors around each particle in the face-centered cubic cell lattice is A4, B6, C8, and D12. All right. So in order to understand this, let's consider a particular cube. Now, in this cube, as it is a face-centered cubic lattice, that means it is going to have the particles at the corners. It is going to have the particles at the corners, right? And the particles on the face. Now, let's consider this particular thing along the face over here, right? So these are the particles along the faces. Now, the nearest neighbors means has to be in immediate contact. Now, if we consider these particular points. Now, if I consider the distance between these two would be the edge length, and it is not going to act as the immediate neighbor. Rather than that, this particular corner, if I'm going to select this particular corner atom over here, this corner atom is going to get connected. It is going to get connected to the nearest neighbors, as if we observe, it is going to get connected to this one, right? It is going to get connected to the just below it, and it is going to get connected to these three. Okay, so these are the immediate neighbors of that particular atom, okay, or that particular particle there. So therefore, if we consider this entire scenario, okay, so at the corner, this particular thing is going to get connected, the particle is connected to three face-centered particles, right? It is going to get connected to the three face-centered particles. But at the same time, when we check that this particular point is being shared by the next cube over here, something like this, by the cube which is facing towards us, something like this, correct? So therefore, again, it is going to get connected to the cube which is on the top. So when we try to take it in a three-dimensional way, that time, this particular particle is connected, okay, it is going to be connected to the others. That is, it is going to get connected to the 8 cubic cells, right? So therefore, as the particle at corner is connected to 8 unit cells. Okay, so therefore, as one corner particle, as the one particular corner particle in 1 unit cell is getting connected to how many we have? That is 3, right? So 3, as the same particular particle is connected to the 8 unit cells. So therefore, 3 into 8 is going to get connected to 24. But here is a twist. Here, these particular particles, now if I'm going to select this particular particle, it is shared by 2. So as every single particle is shared by 2 unit cells, that is particle at center of face, right? As it is shared by the 2 unit cells, what we are going to have is 24 into half, that is going to be 12. So therefore, it is going to have the nearest neighbors as 12. So therefore, our answer here is D.